The next way we'll consider to measure position is called a quartile. Quartiles just give you the 25th, 50th, and 75th percentiles. We denote them with this Q1, Q2, and Q3 to represent the 25th, 50th, and 75th percentile. So now that we have a basic idea of what they are, let's talk about how to find them. Like with many things in statistics, the first step is to order the data. We want it to be in order from smallest to largest. Our Q2, the 50th percentile, is just the median. So our second step is to just find the median. The next step is the median is going to divide the data set into two pieces. So our third step is we're going to find the median of everything less than Q2. And that's our Q1 value. The next step is to find the median of everything greater than Q2. And that's our Q3 value. So essentially all we're really doing is finding three different medians. So let's try an example. Here we have a data set, and these are the ages of the presidents at the time of their inauguration. And I've already ordered the data from smallest to largest. If you count the data points, there's a total of 45 data points. So in order to find the median, we need to split this up into two groups. We can see that if we have 22 below and 22 above, that'll split perfectly. So as we count, we'll count 22 places above, and the 23rd spot, which is this 55, is our median. So that's Q2. To find Q1, we now need the median of all of the numbers below our median. So, like I said, there are 22 numbers there. So if we count 11, this point right here marks the point where there's now 11 above and 11 below. So we now need the number halfway between 51 and 51, which is 51. For Q3, once again, there's 22 numbers. And if we count 11, we have this spot right here where there's 11 above and 11 below. So Q3 is halfway between 58 and 60, which is going to be 59. So now I have my Q1, Q2, and Q3. Now that we've defined quartiles, we're going to formally define outliers. Outliers are extremely high or extremely low values that are unusual for the data set. However, extremely high and extremely low are not very exact, so we're going to make this a little more exact. First, we're going to find our interquartile range, which is Q3 minus Q1. Our third and first quartile, we're just going to subtract them. The lower boundary for our outliers is going to be our first quartile, Q1, minus 1.5 times this interquartile range. So once we find that, we'll multiply it by 1.5, subtract it from Q1. Any numbers smaller than this are going to be outliers. Similarly, we have the upper boundary, where we still multiply 1.5 times our interquartile range, but this time we're actually going to add it to Q3. Any numbers bigger than this are now going to be considered outliers. So now that we've talked a little bit about how to find them, let's see if we can do an example. We once again have our ordered data set of the age of presidents at the time of their inauguration, and we've already calculated Q1, Q2, and Q3. So now that we've done that, we want to find our interquartile range, IQR. And we just subtract our third quartile and our first quartile. And we know that 59 minus 51 is 8. So that's our interquartile range. We then need to multiply this by 1.5. So 1.5 times 8 is going to be 12. We now have to do two calculations. The first one, 51 minus 12. The second one, 59 plus 12. Our first one, 51 minus 12 is 39. So if we ever have a president younger than 39, is going to be an outlier. However, we don't have any there. 59 plus 12 is 71. So if we have someone over 71, that will be an outlier. And once again, we can see that we don't have that.